Let's go through the panic process for a one mean T interval together. Jones Nursery specializes in custom design landscaping for residential areas. The estimated labor cost associated with a particular landscaping proposal is based on the number of plantings of trees, shrubs, and so on to be used for the project. For cost estimating purposes, managers use 2 hours of labor time for planting of a medium-sized tree. Actual times for a random sample of 10 plantings during the past month yielded a sample mean of 2.2 hours and a sample standard deviation of 0.52 hours. Construct a 90% confidence interval for the mean tree planting time. You may assume the original population is normally distributed. All right, so the first thing we do is we give our parameter statement, or basically what we're being asked to do. And here we have a 90% CI mean tree planting time, or something to that effect. The A is going to be our assumptions and conditions, so random sample, normal large, and our sample standard deviation S. So random is stated in the problem. It says they have a random sample of 10 trees, so we can check random off. Our sample size is n equals 10, so it's definitely not large, but the problem does say that it's normally distributed, so we can circle that and put stated. And then while we're here looking at that sample size of n equals 10, the degrees of freedom are going to be 9. So that degrees of freedom formula was n minus 1, and so our n is 10, so 10 minus 1 is 9. And then our sample standard deviation S is 0.52, and that was given to us in the problem. So because we have the sample standard deviation, we have a one mean T as in tiger interval. All right, so to get our interval, we're going to switch over to Excel, and I will meet you over there to put those numbers in and show you how that page works. All right, so here's the same spreadsheet that we used in chapter 16 and 17. We're just on a different tab. So instead of the one mean Z as in zebra, we're looking for the ones that say one mean T as in tiger. And specifically, we want the interval one. All right, so once we're here, this actually works almost identical to the one from chapter 16. We'll put in our confidence level, which was 90%, so 0.90. X bar, our sample mean, was 2.2. Our sample standard deviation S was 0.52, and our sample size was 10. All right, so that gives me endpoints here of 1.9 and 2.5, and we'll take those back to our work on panic in just a second. But I want to look at this T-star value. So T-star automatically calculates here based on the confidence level and the sample size that you put in those yellow colored boxes. In a Z as in zebra distribution, that number is 1.645. But in this one, it's 1.833. So you can see, even though there's a little bit of a slight difference there, that's what was throwing people's results off when they were just substituting their sample mean into the old process. Okay, so I brought our numbers over from the spreadsheet. So the endpoints of our interval for the I part of panic are 1.9 to 2.5. So our conclusion statement here is we are 90% confident the true mean time to plant a medium-sized tree is between 1.9 and 2.5 hours. Okay, so I want to talk about this interval in context of the problem. So in the problem, they said that they're charging them 2 hours to plant these medium-sized trees. So 2 hours is within this interval of 1.9 to 2.5, but this is probably something that if this was my business, I would keep an eye on, maybe repeat this process or repeat it with a bigger sample, just to make sure that I really am covering my costs and I'm billing correctly to my customers.